This is just another version of a phase change graph. And we can see that as we go from left to right along the x-axis, energy is increasing. This one says thermal energy transfer at a constant rate. That means heating it up at a constant rate. Let me get my pen. Yeah. So right here, heating it up, adding energy at a constant rate. And then along the y-axis, we have temperature in degrees C. Notice that right here, we have 0 degrees C marked, and notice that's the flat part, also the first little flat part on the graph. Remember that this part is where temperature does not change, and temperature does not change during what? During a phase change, right? So this is a phase change. This up here represents another phase change. It's one at a higher temperature, so this one must be going from a solid to a liquid, or melting, and then this one would be going from a liquid to a gas, which would be vaporization. And it's occurring at 100 degrees, whereas freezing or melting would occur at 0 degrees. Notice also that freezing and melting occur at the same temperature, and vaporization or boiling and condensing occur at the same temperature. You may be thinking that, I do see water condensing from the air onto the surface of a glass at a temperature lower than boiling. And in fact, that does happen when the temperature is cooler. And we won't go into all the whys. We may discuss that in class. But for right now, just accept that this will happen at this temperature, although it may happen at others. So this graph looks different from the other one, but really it's very much the same. This part right here is the part where we have a solid. See, the purple shaded part says solid, so that means the substance is in the solid phase. And as we can see, as energy increases, its temperature is increasing. So this would be the solid. And then we have the solid to a liquid, and a solid and liquid rather, and that's the point where the phase is changing from solid to liquid, or liquid to solid if we're going backwards. And so we have a little of both. The line here is horizontal. It remains at 0 degrees, so the temperature does not change. And we know that temperature doesn't change during a phase change, right? All right, finally, all the solid has melted. It's changed to a liquid, and we have all liquid. And so this line right here represents the place where we have a liquid, all liquid. This represents then melting, if we're increasing energy, or freezing, if we're decreasing energy. Okay, finally the liquid gets hotter and hotter and hotter until it reaches the boiling point, begins to boil, and at that point some of the liquid changes into a gas. So we have both liquid and gas around. This is a phase change again, and this would be vaporization or boiling. Vaporization. And that's when we're going in this direction. And if we are cooling the gas, if we're removing energy, then it would be condensing, or the phase would be condensation. And that would go in that direction. Okay, so particles get hotter and hotter, they gain more energy, they're flowing around each other kind of fast, and finally some of them begin gaining enough energy that they can fly out into space, and at that point they become a gas. And when all of the liquid has evaporated away, the pot's dry, we now have a gas. And at that point the temperature can begin increasing as we continue to add energy.